Hello guys, welcome back to Ride Academia. It's been a very long time, and for certain reasons, we've been unable to bring tutorials to your doorstep. But we are here again, and then we are trusting God that we'll be in a season of this is going to be a season where we'll be consistent in all that we do. Okay, so first of all, I want to thank you guys for the patience. I want to thank you for the support so far, and then for as many that have been checking up on us. Yes, we appreciate every bit of support, every encouragement. It has gone a long way, and you are the reason we are still standing. Okay, now today we are going to be doing more of a revision class, yes, so that we can pick up on some things that we have done before, and then we'll see how we can journey through. So by observation, I was able to discover that there are certain topics or there are certain things concerning mathematics. Okay, I'm speaking now concerning mathematics, that's calculations, that keeps that keep becoming or that keeps on being a hindrance or a confusion to many people even at the advanced stage. Okay, so today we want to see how we can understand the basic things. Okay, the basic things that we need to know. There are basic things that a person must know in order to build his mathematical knowledge or his mathematical skill. Okay, and then today we're going to be looking at those things because, like I said, by observation, I've seen that many people find certain things difficult at the advanced level because certain basics were not taught or were not learned properly at the junior level. Okay, so today we're going to be looking at basic things. It's going to be more like a series. Yes, we want to see how we can help people understand mathematics even from the grassroots. Are we together? So today we're going to be looking at simple things. Yes, I said simple because they are literally elementary, but they can determine how far a person go in mathematics. Now, I've done a series before on this, but maybe it was not really clarified as this. Okay, so we're going to be going over it again. We're going to be looking at the like terms and the unlike terms. Yes, I said like terms and unlike terms. It is also called in the broad sense, they could call it algebraic expression. But I want to be as defined as simple as possible when it comes to this concept because I feel like this particular topic has become a concern for a lot of people where you don't really understand how to add, how to subtract, what to add and what not to add. So we're going to be looking at it today step by step. We may not be able to do everything in one video, yes, because I want to take my time to see how we can understand this particular concept in its totality. Okay, so we're going to be looking at like terms. We're going to be looking at like terms and unlike terms. Yes. Now let's start with defining concepts because, like I said, I want to be as simple as possible. Okay, it's not about. So I want to see how we can understand everything we are saying now in detail. So when we talk about like terms, okay, that's the first thing we'll be looking at. When we say we have like terms. Okay, now when we say we have like terms means we are referring to algebraic expressions that literally have the same variables. That's just what I can explain. Okay, algebraic expression that carries the same variables. The variables should be same in letter. Okay, you know that in maths we can use letters to represent certain unknown numbers, right? We call them variables because the value can change. Now, so the variables, that's the letters. In case of like terms, we must have the same variables and the same power. Now, I'm not talking about coefficient, okay? I'm talking about the power. Every variable has its power. Every variable has its power. This power is separate from the coefficient. Yes, the power is separate. Now, if you don't understand like and unlike terms, you'll be finding topic like quadratic equation strange, topic like simultaneous equation strange, topic like indices, even logarithm, you'll be finding it strange because you will not be able to differentiate between what you can add and what you cannot add. Are we together? So today let's see and then let's show you what we can add. But starting first with the concept of like terms, okay, where we have algebraic expressions that have the same variable, the same variable, the same power, the same variable, the same power, then we say we are talking about like terms. Simple as it is, yes. Now, this is it. These variables are all carrying x, x, x. Okay, these are all variables carrying x, x, x. But now, what is the difference? The difference is their power. So because they are having different power, we cannot call them like terms. Yes, we cannot call them like terms in terms of addition and subtraction, because addition and subtraction is picky with both the term itself, that's the variable itself, and the power that the variable bears, okay, or that the variable carries. So now we have same variables. Now we have different powers. So, like I said, these are not like them. So, when we say like them, that means the expressions, the variables must be same. So, if we are having y squared and we want to look for a like them, it means we can be having another, the coefficient can be different, yes, but the term, the variable must be y squared as well. So what am I trying to say? If you have y plus 2y, yes, the coefficients are different. That's not our focus. Our focus is on the variable and the power of the variable. So this is it. Y is here, another y is here. The power here is 1. The power here is 1. Of course, you can add this. These are like terms, yes. So you can add them because they are like terms in the terms of addition and what subtraction. Okay, so we're going to be looking at this series. We'll be looking at addition and subtraction in one go. We'll be looking at multiplication, and then we'll be looking at division. Okay, so we're going to be like we'll have to see everything step by step, so that as we build up on other topics, we'll always have a reference to this particular video. Are we together now? So we can add this like I was saying, because the variable is same. It's y here, it's y there. Okay, and then the power is the same. This is y raised to power 1. Mostly whenever you see a variable without power written on it, it means that the power is that means it's raised to power 1. That is, the power is 1. Are we together? So now these are like terms. So it's possible to add them. Now, how do we add like terms, or how do we subtract like terms? That's another question. How do we add like terms? Once we've identified that these are like terms, then we can add or subtract them. So how do we add or subtract like terms? We now look at the coefficients. We look at the coefficient. What is the coefficient? The coefficient talks about the number that is multiplying the variable, not the power. Yes, there's a difference between coefficients of a variable and the power of the variable. Okay, so the number that is multiplying the variable. So in the case where you don't see any number, like I said, you don't see any number up for the power, it's raised to power 1. Also, in the case where you don't see any number in front of this variable, because numbers always come before the variable itself. So in the case where you don't see a number before this variable, then the coefficient in this case is 1. Are we together? So this is it. Our coefficient here is 1. The coefficient here is 2. So how do we add or subtract? Once we have identified like this, we can add the coefficient in the case of addition, or we can subtract the coefficient in the case of what? Subtraction. So this is it. So we have 1, that is 1y is y, okay? Y plus 2y, okay? So this is like 1y, because we don't write 1 in front, okay? Plus 2y. So you add the coefficient 1 plus 2 to give you what? 3y. Now, you don't add like terms and then multiply or increase the power. The variable and the power still remains intact. The variable and the power still remains what? Intact. So I did not alter the power. Don't go and start adding and say it is 2y squared or 3y squared. So sometimes we mistake this whole thing. We mistake addition and multiplication, and then we see that we may be getting some things right, but because of basic things like this, then we'll now be having wrong answers. Okay, we'll be having wrong answers, and then maybe another type of confusion along the way. Yes, so this is what it is when you add variables like terms together. You don't add, you don't increase the power, you don't change, the variable remain constant. The only thing that you add is just the coefficients. Are we together? It is just the coefficient. Now I like to use this example most of the times because maybe we can really relate more. So if we have 2 oranges and we have three oranges as well, we have 3 oranges. The same way you cannot add this to become 5 orange square. Yes, we cannot add this to become 5 orange square. If you had 2 oranges before and somebody gives you 3 oranges, you cannot really say you now you have 5 oranges square. You don't just add and then you begin to multiply power. When you are adding, the only thing we are adding is coefficient. But before we can add or subtract coefficient, you have to check if it is a like term. So there is a condition that you cannot add or subtract just any expression. That expression you are planning to add or subtract, or that expression that you want to add or subtract, must be a like term. They must be like terms. They are supposed to be like terms, okay? And by like terms, like I said, we are saying same variable, same power, same variable, same power. So if you have same variable, different power, you are talking about unlike terms entirely. So now let's look at something else. Let's say we have to simplify. This is minus 4x plus 2x squared minus 3x plus x squared. Let's go for this, okay? All we have here is just we have algebraic expression lined up and we want to simplify this. Yes, we want to simplify this. Now, the first thing you need to do, because like I said, you cannot add unlike terms. This is x, this is x squared. X and x squared are unlike terms. You cannot add them. But we have x and x somewhere along the line. We have x squared and we have x squared. So what we're going to do now is, because this and this are like terms, and this one and this one are like terms, we are going to do something called collecting like terms. Yes, collecting like terms is another area where people can also make mistake, because there's a rule that guides collecting like terms when there's an equal to sign, okay? When variables are going over the equal to sign, there is a rule. That is when you begin to change power. If a minus goes over the equal to, become plus. That is where the rule applies. But in the case of a simple expression like this, there's no equation here. So whenever you are rearranging or collecting like terms, you don't begin to change signs. No, you move with the signs just as they are. Okay, so this is it. I want to collect like terms. I want to bring this person close to this person because they are like terms. Now look at the coefficient. The number, like I always say, that a number can either be positive or negative, but every number has their sign in front. Every number have their sign in front. So every number you can see have the sign. It's only when you have a positive number coming first that you can ignore the plus sign. But once it's a negative number coming first, you see that every number have their sign in front of them. So for this like term, which is our x, the coefficient is minus 3. As we are moving it, we are carrying it plus the coefficient. We are moving it and the coefficient to go and meet minus 4x, okay? Now, so we are going to be having minus 4x. I'm not changing the sign because there was no equal to. This one is not going over any equal to sign. So the sign will not change. You have minus 3x, okay? Same as it was. Now you arrange these ones together. So the sign also here is plus. Okay, so you have plus 2x squared and then you have plus x squared. Okay, with this we've collected like terms. And I say once you have like terms collected, what you add is just the coefficients. What you add is just the what? Coefficient. Don't go and start adding different things. Don't go and start adding powers. This is where the many mistakes we make at the advanced level start, okay? The mistake always start from little things like this, little topics like this, okay? So when you want to add, now we have we have confirmed that this is a like term. This one also, these ones are like terms, okay? We have confirmed that these are like terms. The next thing you do is, like I said, you add coefficients. Minus 4 is the coefficient for the first x. Minus 3 is the coefficient for the second x. So what you do is that you add minus 4 minus 3. I'm saying add, yes. So even if we can add or subtract negative numbers, are we together? So how do we add minus 4 minus 3? Minus 4 minus 3, like I like to use, when we are adding numbers, integers, right? I like to use a system or a simple method that is called the owing and having system. It's very easy to understand. Yes, very, very easy to understand. Yes, I know that I'm saying a lot in this video. So it's very, very easy to understand. It's something called the owing and having system. Yes. So whenever you are adding or subtracting, that is for addition and subtraction. We are still on the series, right? whenever you are adding or subtracting, a negative number is assume you are owing. Okay, whenever you see a negative number, you assume that you are owing. Then whenever you have a positive number, assume that that is what you have. Okay, so it will be easier for you to add and subtract using that system. Now, -4 means you are owing 4 naira, you are owing somebody 4 naira. -3 means you are owing somebody, that same person. So this is previous owing and current owing. Okay, you are owing this person 4 naira, you haven't paid. Now you are owing this person 3 naira now. So the thing is that the debt will only increase. Okay, what you are owing will increase because you've not paid any amount of money. So -4 -3, like I said, we are only adding coefficients. -4 -3, you are owing 4 naira previously. Now you are still owing 3 naira. Your debt will increase. So now you are owing 7 naira. So you have -7x. Mind you, it is x. I did not go and add power. Don't go and start saying -7x squared. That is a different thing from what we are talking about. When you are adding, do not touch the variable. Just work on the coefficients. Once you've identified that they are like terms, your emphasis or your focus should shift to the coefficients. Are we together? Once you've identified like terms, the emphasis to shift to the coefficients, and then you add the coefficients to have your answer. Now you are through with this first one. Let's go to the next like terms. The next set of like terms. Now we have x squared, they are like terms. The next thing, our focus goes to the coefficient, the number multiplying the variable. In this case, this is our coefficient 2. In this case, like I said, whenever you don't have a number, you cannot really see a visible number, then the coefficient is 1. Okay, the 1 is usually invincible. Are we together? So we have coefficient also, we want to do it. This is 2 plus 1. 2 plus 1. Coefficient. Okay, coefficient. So 2 plus 1 be giving us what? Plus 3x squared. Mind you, as I said, I did not touch the powers. I did not even tamper with the variable or the power. Before you go and add and begin to add powers, you are doing something entirely different. Are we together? So this is it. Whenever, let me go over this again. In summary, whenever we are adding or subtracting algebraic expression of any kind, our focus is on adding or subtracting only like terms. We can only add or subtract like terms. And what are like terms? Like I said, in the case of addition and subtraction, like terms refer to variables that are the same. Okay, the same variables, the same power, the same variables, the same power. Like I told you, x raised to power, just x is different from x raised to power 2 because the powers are different. So you cannot add x like we just did here. You cannot add x and x squared because they are unlike terms. You can only add or subtract like terms. So this will be all for today. Don't forget to like this video, subscribe to this channel if it was helpful to you, share this video with as many as you can. Yes, as many as you know that you love them to be a part of what we are doing here, a part of this training. Share this video with them. Subscribe to this channel, like I said, if you haven't, and turn on the notification button so that when new videos drop, you'll be notified immediately. Okay, so we'll see you in our next class. Thank you.